When you go back, the market 10 years ago was a 0 to 2 hour market. It's now stretched to 4 hour. And when people start talking 6 hour plus, we show the benefits of our system. And what I knew from my prior career was this was one of these generational secular shifts in the industry that if you can bring the right product to market, you have something that can capture a large demand curve.
This is EnergyCast, and I'm Jay Downhauer. Today we're talking about a commercial solution for rechargeable zinc batteries. You may be asking, who cares about zinc or any other batteries? We got lithium ion, and they're going to power our cars, our computers, and back up all of our wind and solar. It's a point I bring up with my guest. I think lithium ion is critical for electric vehicles. You'd be hard-pressed to find anything lighter. But when it comes to stationary storage, backing up all our electric generation on the grid, do we need lithium ion batteries for that too? I also ask about the supply chain for lithium ion. I'm not sure you could build a lithium ion cell if you were confined to the northwestern hemisphere. My guest understands this issue. In fact, he says his batteries come down to 5 ingredients. All can be found locally, and all are widely available. Zinc, as I mentioned in the beginning, is one of those ingredients. Zinc oxide batteries have been around forever. We grew up with them. But as I discussed in episode 56, you can't recharge them. My guest back then at the Naval Research Laboratory explained that zinc batteries will form spiky microscopic dendrites, which will eventually puncture the membrane, touch the cathode, and short out the cell. My guest in that episode had developed a lab-scale zinc sponge configuration, which would space out the zinc enough not to form the spikes. My guest today has added their own spin on zinc, which should keep the spikes at bay forever. These developments finally bring common zinc oxide batteries into the energy storage revolution, which I probably discuss every other episode. It's innovations like these that are giving the energy sector more options for making energy available when it's needed. My guest today is Joe Mastrangelo, CEO of EOS Energy Storage, a technology developer based in, appropriately enough, Edison, New Jersey. EOS has been around since 2008. They specialize in an aqueous zinc battery, which they call Zinth. As we discussed in the interview, EOS believes they can capture the growing market demand for battery storage that can last beyond 4 hours. Joe has a distinguished career. He was GE's CEO of their power conversion and then gas-powered systems divisions. As you hear him explain in the interview, he was drawn to energy storage and the potential a technology like this could provide. Now he finds himself leading a company that is working to make large customers comfortable with the advantages a battery like theirs can provide. I hope you enjoy my conversation with Joe Mastrangelo. We're here with Joe Mastrangelo, CEO of EOS Energy Storage. And Joe, I first covered rechargeable zinc battery technology back in early 2019. That was a zinc sponge technology that prevented the batteries from developing spiky dendrites. This was with the Naval Research Laboratory. How do your batteries compare to that? Is that what you're also trying to solve for?
Yeah, Jay, it's a great question. We are a hybrid technology. And if you look at what the team has done over the 12-year history of the company is we've developed this technology where we've eliminated the dendrite issue really with 4 main things. It's the composition of our electrolyte that we use in the battery. It's how our chemistry works with the cathode. Those are 2 of the big drivers of the prior dendrite, which we think we know we've solved from the testing and field data that we have. And then additionally, the 2 other things is we've chosen a depth of pool in each of our cell modules that eliminates and gives us the distance where we don't need a membrane or a separator to be able to drive our chemical reaction. So therefore, that's another driver of what is called dendrites and other batteries. And the last piece is the zinc plating process that we use, and some of the additives that we've put into our electrolyte formula allow us to get a much smoother zinc plating on performance and gives us the product that we have today out in the marketplace. So for us, we're not a flow battery, nor are we like lithium ion, and that's why we call ourselves a hybrid. And our great team of chemists being led by Francis Ritchie have done a great job of eliminating that risk.
One of the issues I think that's associated a lot with lithium ion is the number of cycles that you can do. It's gotten better over the years, but how many cycles do you think you can get out of these batteries versus maybe the lithium ion? The same, better?
To your question on dendrites, just the way the chemistry works and our cathode anode, every time we're cycling the battery, you're resetting the chemistry. We see a 15 to 20 year life out of this system, depending on how you operate it, which is significantly more than what you would see coming out of a lithium ion system. And a lot of that has to do with the fact of our technology being specifically designed for stationary storage and designed around longer duration stationary storage. And the way that we've done that allows us to offer a longer product life cycle.
Joe, I'm a huge energy storage supporter, and I'm concerned about lithium's capacity to be everything to everyone. I mean, right now we're talking about replacing all vehicles will be lithium ion, all generation backup will be lithium ion. Is the energy sector starting to see that too, that there needs to be room for other technologies for storage?
Yeah, and it's really when you start to hear the industry talking about longer duration storage. And the way that I look at this over my nearly 30-year career in the industry is that there's always going to be a mix of technologies required to meet the energy needs of the world. I think lithium meets the EV market. It's a great product. The shorter duration discharge market, it's a strong product. When you start looking at beyond 6 hours, I think you look at and see some of the weaknesses that you see in lithium systems and then wanting to have alternate technologies. And there are companies out there like us developing technologies that can go beyond 4 hours. You look at our latest generation of product, we can do anything from a 3-hour discharge up to a 12-hour discharge with the same system. And I think that's critical when you start looking at the mix that we need as renewables become a bigger part of the energy mix. So I don't think one size fits all. And even we would say we're not a product that fits every application. And I think we're going to need a mix of those technologies to get to the goals that we have as a society and a world as we really try to decarbonize our energy value chain.
Right. I'm a big supporter of the everything, everywhere, all the time. This. A big criticism of lithium ion is the long supply chain. I don't think many people realize this, but look, a lot of companies in China, there's controversy over the cobalt that's needed. I recently interviewed a guest who's making lithium mining more sustainable, but those operations to get most of the lithium for the world are in Chile. Does your battery have a shorter supply chain than that?
Yeah, so the way that we looked at how we wanted to position the overall system development of our product, we have 5 main raw materials, all of which are earth abundant, conflict free materials used in other industries. And the way that we specified our product was we took each one of those 5 elements and said, let's go out and find suppliers that are producing a product for another industry so we get into an established supply chain that has scale and quality. And that's how we thought about the product. So you've got titanium, graphitized felt, zinc, bromine, and plastic is really what we have in the battery. And it's a supply chain that can scale up. And we're a very insignificant portion of the overall use of those raw materials when you look at the other applications where those materials are used in. So we try to design something that we'd be able to scale with. And as we scaled, we get cost synergies coming down as we added volume into our business.
Yeah, this need to diversify the batteries that we use. One of the problems with a lot of these early adopters is I think they sometimes get married to one technology. I spoke to a utility who's installing grid scale storage, and when I asked what they were using, they told me they'd settled on, for instance, Samsung lithium-ion units for the time being. Is that a challenge for you, these developers who are getting wedded to a single supplier or technology? How do you break that decision of this to basically settle on one technology?
This comes down to our commercial process and how we sell the differences in our technology versus other technologies that are out there. And I think when you go back, the market 10 years ago was a 0 to 2 hour market. It's now stretched to 4 hour. When people start talking 6 hour plus, we show the benefits of our system. And then I also think when you look at how our system works, we just work relentlessly with customers to explain to them the safety factor in having a battery that's non-flammable, non-toxic, fully recyclable at the end of its useful life. The ability to run multiple use cases to create revenue stacks and allow you to address different aspects of the market that you want to serve, and just getting them to understand how the battery fits into the model that they've been working with. And really, when you look at where the market is going, we've made a lot of traction. We've got a backlog approaching $100 million and a pipeline of close to $5 billion in opportunities. And we just work those one by one to get people to understand our value proposition and how they're thinking about their return on investment and how we match up the two. It's a lot of hard work, but that's why I think we've got a great commercial team that's just out there every day grinding it out and showing people what we have.
it makes me think, is there a push to maybe try to standardize how the interface looks for customers? It doesn't really matter what the battery chemistry is. It should just basically matter how utilities and the other clients are interfacing with it. Would that help with adoption?
The way we initially approached the market, and again, it depends on the segment that you're in. The way we thought about this was we sell a DC system as our core offering. And that DC system comes with a battery management system that is agnostic to the energy management system that our customers using. So low switching costs. So what we thought about was like, as a new entrant to the market, you're not going to be able to walk into a large utility and say, we have to retrain your workforce on how to run our system. We were agnostic on how we interface on the software side, and then agnostic on how we interface on an AC inverter side to allow people to use equipment that they're familiar with. Now, that holds true, particularly with the large utility, large developer segment of the market. This behind the meter, smaller segment, there are people that are looking for turnkey solutions where they don't have the engineering and technical resources that a large utility does, that comes and says, you tell me what's the best option. And we're seeing that more and more in smaller projects that really make us rethink, do we need another strategy as we look at that market? But yes, I think you have to have a system that plugs in and can get to scale and allow ease of use.
Yeah, I've been speaking to battery guests ever since the beginning of the podcast. My first battery guest was a company called Alevo that was based here in Charlotte, and they folded not long after I spoke to them. One of the issues seemed to be the value proposition at the time. Is this generation? Is it a transmission asset? Is that still an issue, or do we think we've solved how this is fitting on the ledger?
Part of the way that we thought about scaling up our company was we tried to design everything in a module basis. So even our factory capacity can be built out in individual manufacturing lines to take a factory that can start off with as little as 200 megawatt hours of production and scale that up to as large of your square footage. Because I think when I went back and looked at a lot of the companies that struggled around industrialization, they struggled around the fact that they created capacity waiting for the market. And then when the market wasn't timed to where their capacity was, or the product didn't have the returns that they thought in the market and they couldn't scale, you wind up failing on the fact that you have underutilized capacity and you're absorbing all that cost. So the way we're trying to do this is grow capacity as we grow backlog so that we effectively use our capital. I think from a use case standpoint, when you think about the value proposition of where we go in, I think about this as having watched the wind and the solar development and rapid growth of both of those segments, and knowing that our product has to be able to come down a rapid cost curve to be competitive. And that's how we've positioned ourselves, and really looking at taking the forecasts for cost and assuming that we need to be lower than that, and managing and running the company to those targets is the best way for us to get there and really scale EOS for the future.
You partially answered this earlier, but what would you consider your units to be? Short-term generation like lithium ion, or long-term?
Yeah, so what I would say is we're longer duration. As I said before, we can do anything from 3-hour to 12-hour energy discharge time. Where we really start to see an advantage is when we go above 4 hours, because of the scaling of our system and how our system operates. But we really look at this as the company was always designed. It started off with a vision of solar plus storage 4-hour. And as we've learned and the market has evolved, we've realized that we have a product that can go all the way up to 12 and be very competitive and very cost competitive and deliver great returns for customers. And that's how we think about the product that we put out in the field today.
Yeah, I think this is what you would call energy arbitrage. Curious what you think that might be as a business solution for batteries. I spoke to a compressed air energy storage company that's essentially storing energy on Texas's ERCOT wholesale market and then generating when prices are higher.
We do see in the market this decoupling, where whenever we talked about energy storage before, it was always something plus energy storage. You're starting to see more and more standalone energy storage where customers are looking to find nodes that have the ability to arbitrage on supply and demand, and you could pull power being agnostic to the power you put off on the grid, but when there's periods of low demand, storing it and then putting it back on high demand. So we are starting to see that grow. Still, our largest segment today is solar plus storage, but there is a big opportunity for this as we move forward, given just the way that the intermittencies that renewables are adding to the overall energy mix. You don't really need to be co-located with the solar or the wind facility now. You can be somewhere where you can reduce your transmission costs by being close to a substation to be able to get on and off the grid quickly and easily.
I haven't looked at it lately. What is going on with the financial incentives, specifically with Spikeless storage? Have they decoupled that yet? Are you still getting the tax benefits, if you will, for capitalizing your project by combining it with solar?
Yeah, it's still required. There is no standalone investment tax credit. It is part of the current infrastructure bill that's going through Congress and the House that we're hopeful to see that get approved, because I think that does accelerate not only these new projects that we're just talking about on a standalone storage basis, but also some opportunity to retrofit back to existing solar and wind installations to add storage to them. So it's a key thing that we'd like to see get through here and be able to really, I think, accelerate the uptake of energy storage.
Absolutely. And then, Joe, you have an interesting career. You took over EOS after serving as CEO of two of GE's power groups, the more conventional power groups. So how did you find your way to batteries?
When I came out of GE, I had this idea of now's the time I want to sit back and think about what I want to do next. And as things happened, 2 months into that, I got a call to come talk to the board at EOS at the time. And what I knew from my prior career was that this was one of these generational secular shifts in the industry that if you can bring the right product to market, you have something that could capture a large demand curve. And just the challenge of being able to take this technology. And that's how I wound up in EOS. And what I love about what we do every day as a team is we are truly pioneering something here. And every day that we do something, we move ourselves further out into this energy storage, alternate to lithium ion technology. And it's a great intellectual challenge and the ability to truly make the world a better place. And that's what really drove me to come to EOS a few years ago.
Yeah. And look, this reminds me a lot of when I worked in the fracking sector. I think you're going to see a lot more projects, renewable projects, yes, but a lot of standalone storage projects that are not the biggest facilities in the world. They're smaller, but I think that creates a lot of opportunities for companies like yours to just use smaller distributed generation, if you want to call it. Seems like it's a big sandbox to play.
Yeah, I think the analogy of how fracking shifted the oil and gas industry and took the United States from a net importer to net exporter in less than a decade, I think you're right on. And just the way that that was done and the way that we can operate our technology, there's similarities. I mean, we are a lot more sustainable when it comes to how the technology works and where we get our raw materials. So it just brings this aspect of a great ESG product that helps us shift to a more sustainable energy infrastructure. But you're right. The way I think about this is we have the opportunity to democratize energy if we do this the right way and really maintain a large grid infrastructure, allow everyone to be connected, but at the same time, give them independence and security of supply.
Yeah. And look, it's early days. And one of the fun things about companies like yours is the possibilities are kind of endless. There's a lot of different directions you can go. So where do you think is the easiest way to get into the market quickly? Like, what are you finding to be the sweet spot?
Behind the meter developer market, we've seen a lot of ability to provide solutions that make projects financially viable and provide value to our customers. At the same time, we are working through with big utilities to look at utility scale projects, but those have a timeline on them that are sometimes different than what you get in the smaller projects. So what we're trying to do, as the way I think about this, is find those small opportunities to build up your credibility and your operating references and show the potential of the technology while working through to get qualified with the larger customers to be ready for big projects where when you really look at the uptick in where the growth is going to come, you're going to start to see growth in 2023, 2024. And then you go back, Jay, to something that you said earlier on lithium ion with EVs. And when you look at what's happening in the shift to the EV market and where lithium ion is going to serve that, then you're going to need alternatives for stationary storage. And we want to be ready to meet that demand on that timeline.
All right. Joe, I'm going to finish with a lightning round of your thoughts on different energy technologies, starting with natural gas.
Natural gas is a great transition fuel, and I think is one of the fastest and quickest ways to bring large blocks of power onto the market. I think we're going to continue to see as gas turbine efficiencies improve. I think there'll be a market for natural gas as we move forward.
Crude oil.
I am amazed at how rapidly the automotive industry is switching over to EVs. And I think what's to be seen here over the next couple of years is what happens with larger forms of transportation and how does that evolve and what do we do? But certainly around transportation, it is switching to electrification at a rate of speed I've never seen before.
Nuclear.
To be seen. We're going through, again, wanting to have small, medium-sized reactors. There's a lot of retirements coming online. It's extremely capital intensive to build a project and capital intensive to run a project, although it is a relatively inexpensive form of power. I think to be seen on will this small, medium wall reactor become a reality.
Coal, and I'll add coal with carbon capture.
I think the cost of that starts to increase. It's another thing that we've looked at before. I think the thing to look at is, will it work? I mean, obviously, coal in and of itself, there's a lot of retirements going on around the world and shifting to other energy sources, and we just have to watch that here. I'm a little bit skeptical around it being able to economically compete against some of the other technologies we have evolving in the marketplace.
Wind.
The shift to offshore, the larger size turbine, it's almost becoming a baseload technology.
Solar.
Right now, really high growth coupled with storage, it makes it a very viable long-term play into the energy mix.
Biofuels.
A lot of work going on there. I think my question is around scale and ability to be able to capture the market, given what's happening on electrification. Is it a niche or is it something that can go to large scale?
Hydroelectric.
Low-cost energy, once it's implemented, need to see what the long-term growth from where we are, hard to be determined. Opportunity to couple it with pumped hydro storage makes it a lot more effective.
Geothermal.
It depends on the size and the scale that you're looking for. This could be one of those smaller project ability to deliver very focused energy. But when you really look at scaling that technology, can you scale it up to where it can do something meaningful from a grid perspective?
You guys, energy storage.
It's early days. And then how do we delineate and come up with the segments that we need? And we need more than a technology to be able to achieve the goals that are out there. And we have to understand that.
Electric vehicles.
As I said on your question on oil, this is one that is evolving at a rapid pace and really becoming mainstream.
Energy efficiency.
I think this is going to be the key as we move forward. And I think that the equation, as you move to more renewables in the mix, the way we thought about energy efficiency is going to have to change from the way we thought about it when we were in much more of a hydrocarbon environment.
And then finally, fusion power.
I know I've been reading some advancements in the technology, probably a longer term play of how this is going to fit in there when you look at what wind, solar, and energy storage could provide.
All right, Joe Mastrangelo, EOS Energy Storage, thank you so much for your time.
Jay, thank you. It was great talking and really enjoyed the conversation.
That was Joe Mastrangelo, CEO of EOS Energy Storage, a zinc battery developer. About a month before this recording, Secretary of Energy Jennifer Granholm visited EOS's headquarters in New Jersey. She used the visit as a venue to announce DOE's Energy Earthshot initiative, with the goal to reduce the cost of grid-scale, long-duration energy storage by 90% within the decade. I want to thank Joe for his time, as well as Lori Stern at Soulberry Trout for setting this up. You can find plenty of pictures for this episode on energy-cast.com. As well as on Instagram and Parler at Host Energy and Twitter at Host Energy Cast. All guests are sent the raw and completed audio of the week of release. So far, no complaints. Be sure to leave us a positive review on iTunes. That gets the word out. Music was produced by Sean Stroop at Stroop Loops. That wraps up episode 121. Be sure to join us next week when we learn how 3 utilities are leveraging up strategic partnerships to start new renewable energy ventures. Until then, I'm Jay Downhauer. We'll see you next time.